I want you to picture the nerve center of some massive operation. Think about a broadcast control room or maybe a security hub.
Right.
You've got that gigantic video wall right in front of you, dozens of feeds, satellite data, live streams. Everything's just perfectly synchronized. It looks completely seamless.
That's ultimate image of control, isn't it? But,
Yeah.
most people just stare at the screens.
Yeah.
They completely forget about the controlled chaos that's happening in the server rack just behind the wall.
Exactly. And that is where we're going today. We're going to ignore the pretty screens for a bit and look at the hardware that actually stops that video wall from, well, crashing.
Ah, the unsung hero.
We're doing a deep dive into the Kramer HDCP-IN8-F64.
That is a mouthful of a name, but in the Pro AV world, this 8-channel DVI input card is doing some serious heavy lifting.
We've got the tech specs here from HDTVSUPPLY, and our mission today is to use this one card as a case study, really. We want to unpack how these modular matrix switchers actually work.
Okay.
Because looking at this thing, it's not a standalone box, right?
No, not at all. And that's the first key idea here. This is a component.
Okay.
Think of it like buying a really high-end graphics card for a custom PC you're building. You don't just leave it on the desk.
You slot it into the motherboard.
You slot it in. In this case, this card is made specifically to slide into the VS6464 series modular switchers.
Which is basically a giant chassis for all your AV signals. So modular just means you're not stuck with a fixed number of ports. You buy the chassis, then you slide in a card like this Kramer to add, 8 inputs at a time?
8 separate DVI-D inputs per card. It lets you build a system that fits the room instead of, forcing the room to fit some pre-made box.
Okay, I have to play devil's advocate for a second. Looking at the board, these are DVI connectors. To the average person, DVI seems a little old school, especially compared to HDMI. So why are we seeing DVI ports on a modern high-end card like this?
Yeah, that's a common thing people get wrong.
Yeah.
In this world, the connector type is really just about the physical shape.
Okay.
In a permanent installation, you want a connector that physically locks in, something you can screw down tight. DVI is great for that. But the signal traveling through it, that's pure HDMI.
So you get the physical security of a DVI screw, but it's speaking the digital language of HDMI.
Precisely. And that brings us to the HDCP part of the name.
High bandwidth digital content protection.
Right. So if you're routing a protected, say, broadcast feed to that video wall we imagined, you need that digital handshake between the source and the screen.
And if this card wasn't HDCP compliant?
That multi-million-dollar wall would just show you static, or more likely just a black screen, nothing.
Okay, so it handles the copyright handshake and it translates the physical connection. Let's talk speed, because the spec sheet here lists a max data rate of 6.75 gigabits per second.
Which breaks down to about 2.25 GBPs per graphic channel.
Why does that specific number matter for the listener? Is it just about, higher resolution?
It's about density and fidelity. We're not just moving static spreadsheets around here. This kind of bandwidth supports features like 3D pass-through, really complex visuals.
I see.
If you choke the bandwidth, you get lag, you get compression artifacts. In a control room, you absolutely cannot have artifacts masking your data.
It has to be pixel perfect. And the operating specs 0 to 40 degrees Celsius. This thing clearly belongs in a climate-controlled server rack.
Absolutely. It generates a good amount of heat. It's drawing around 20 watts of power just to process those 8 streams all at once. It's definitely not something you'd throw in a desk drawer.
Which brings us to the price. HDTVSupply lists this at around $3,900.
Yeah, discounted from an MSRP that's nearly $5,000.
That feels like a steep price for a single input card.
It is, until you calculate the cost of failure. This is enterprise-grade stuff. You're paying for the rock-solid reliability of that 6.75 GBPs throughput and the guarantee that the HDCP handshake works every single time, 24/7.
It just have to work tax.
That's a good way to put it. If that card fails during a rocket launch or a live broadcast, it's going to cost a lot more than $4,000.
So if we boil this all down, this Kramer card is the heavy lifter. It's taking 8 distinct, high-bandwidth fire hoses of video data and just funneling them cleanly into one system.
It's the infrastructure that really makes the so-called magic of the video wall even possible.
It's a good reminder. We live in this consumer world that's obsessed with wireless casting and tiny little streaming sticks. But when it really, truly matters, the professional world still relies on heavy iron like this.
Well, physics hasn't changed. When you need zero latency and absolute fidelity for mission-critical video, you still need copper and you need robust hardware doing the processing.
Something to think about next time you see one of those massive, flawless displays at a concert or a command center. There's probably a $4,000 card somewhere in a back room, sweating to make it all happen.
Yep.
Thanks for listening to this deep dive.
See you next time.